Hello, everybody. This is Clyde, O&amp Race Blogger Podcast number 58. It is October the 2nd, 2018. And we're reading from the September 2018 OPEdge.com magazine. And this is Industry Review. And article is E-whiskers may have prosthetic application. Researchers at the University of Texas at Dallas have developed artificial electronic whiskers they believe are a significant step toward engineering electronic human skin and providing sensory information to prosthetic limbs. The work is described in a paper published in the journal Advanced Materials. Animals' whiskers are touch receptors that send information about the animal's surroundings to their brains to help them interpret the environment. For example, seals' whiskers provide information about the location of fish by disturbances the fish make in the water. Intrigued by the hair's versatility, the researchers used shape memory polymers to create artificial electronic whiskers. Outlines of the E-whiskers were cut from a flat sheet of shape memory polymer, which is rigid at room temperature but becomes flexible when heated. A flexible strain sensor was patterned on top of each whisker, which had about the same diameter as a human hair, and remained attached to the sheet. When researchers blew hot air through the bottom of the cutouts, the material became soft and bendable, allowing the fingers, the E-whiskers, to rise and become three-dimensional. Once the E-whiskers were assembled, disturbances induced changes in the resistance of the strain sensor that allow for the precise tracking of each E-whisker position. We've created some of the highest density of E-whiskers to date, said Walter Voigt, Ph.D., an associate professor of materials science and engineering and mechanical engineering at UT Dallas, and an author of the paper. When you have a lot of sensors like this that can be dragged over a surface, you can then use them to measure many interesting properties. Our E-whiskers were able to detect force, pressure, proximity, temperature, stiffness, and topography. As they brush up against or whisk across various materials, they mimic the sensing capabilities of human skin. Along with prosthetic devices, the researchers believe the E-whiskers could be used in robotics. Many robots already collect tactile information from their physical environment. However, traditional sensors lack the complexity and richness of human touch. With E-whiskers, we can increase the types of information that can be obtained when grazing a sensor across a surface, said Jonathan Reeder, Ph.D., the lead author of the study who conducted the research as a doctoral student at UT Dallas. Integrating electronic sensors directly with biology is the most compelling application but presents a set of tough challenges, said Reeder, who is now a postdoc researcher at Northwestern University, namely, how to translate electronic signals generated by the sensor into the language of the nervous system, and how to form a stable mechanical and electrical coupling between the flexible electronic and the soft tissue. That's kind of an interesting article from Industry Review. Next article is Switchable Compliance would reduce prosthetic wrist users' compensatory movements. It's a short article. Insufficient degrees of freedom in prosthetic wrist joints force users to make compensatory movements which can result in residual pain and overuse syndromes. Well, a new study's findings indicate that the optimal compliance for a prosthetic wrist is specific to the phase of the motor task. A compliant wrist outperformed a stiff wrist during the reaching phase, whereas a stiff wrist exhibited more natural movements during the manipulation phase of heavy objects. Based on the results, the study's authors encouraged development of prosthetic wrists with switchable compliance. The research team from the Biorobotics Institute of the Scuola Superior St. Anna Pondetra, Italy, hypothesized that a transradial prosthesis would allow simpler operation if its wrists were compliant during the reaching and grasping phase. and stiff during the holding and manipulation phase. To assess the hypothesis, the researchers compared a stiff and a compliant wrist while evaluating the extent of compensatory movements in the participants' trunks and shoulders. The unimpaired participants used orthoses as they performed 9 activities of daily living from the Southampton Hand Assessment Procedure. The study was published in the IEEE Transactions of Neural Systems and Rehabilitation Engineering. Next article. Upper limb prosthesis users rely heavily on intact limb. People who use myoelectric arm and hand prostheses still rely heavily on their sound side. Researchers from the University of Salford, England, have found adults without amputations demonstrated reliance on both upper limbs. Wow, really? In the open access study, published in Scientific Reports, researchers used electronic sensors to observe daily activities for 1 week among 20 people, 14 men, and 6 women.